Okay, good morning, ladies and gentlemen. This is Professor David J. De Los Reyes. What I will be discussing this morning will be it's the use of my assembled what do you call this assembled DC to DC converter. Uh, a while ago, I assembled this one. This is just a recap. This is a DC to DC converter. This is the rectifier and voltage regulator portion. Okay? The output of this voltage regulator is inserted on the input of the DC to DC converter. Okay? And this is the terminal of the DC to DC converter. The significance of this DC to DC converter, if we try to input a certain voltage here, I will just repeat it. This is just a recap. It's either that the output could be lower than the input voltage, or the output could be higher than the input voltage by just manipulating these knobs here. A while ago, I adjusted already the voltage adjustment because I wanted that the voltage output of this one will be 5.5 volts. And what's the significance of this 5.5 volts? This 5.5 volts I used to charge a power bank. We got a power bank here. Normally, if we charge this one by using the given, what do you call this, charger, we plug in this one, and of course, here's the other one. Then we plug this one to the outlet, right? Of course, this is connected if we try to use this one. But I don't want to use this one. I would like that I will be using my DC to DC converter. Okay? The voltage output of this one is actually 5 volt. I think this is 3.7. So this one will be 5. We are charging a power bank with the voltage thing of 5 volts. So it's fine. What I will be doing is that I will be using my DC to DC converter. It's more what you call this powerful than the than the charger being given to us. There's no comparison with this one. This is much stronger than this one. Much stronger, but for sure it will not overcharge our battery because we try also to maintain the voltage output at the terminals. What is given on the charger. Whatever the voltage here, we will copy it here because actually we could actually adjust the voltage output of this one. And a while ago, I adjusted this one already to 5.5 volts. I don't want 5. I want a little bit higher. Anyway, if we are charging at 3.7 and the voltage, charging voltage is 5.5, it's fine. Because when it draws current, that voltage 5.5 might go down to around 4. So 4, compared to 3.7, it could still charge it. Because when it draws current, of course, that 0.5 volts will decrease. So I would like now to show you that the voltage output of this one is actually 5.5. I'll plug in this one, and like what I said, I adjusted already the voltage output of this one to 5.5 volt. Okay, and let's try to see if it's really 5.5 volt. Okay. I got a multi-tester here set to measure DC voltage. Uh, I did this one myself, so I don't want that I will be making mistake in the connection of the plus and minus. They are both black, so for me to know which is the positive one, I place a red thing here. This one will be with the positive terminal because I don't have a red wire here, okay? And this black thing is the negative. So I will be connecting this ground to the negative terminal of the battery, what they call this multi-tester, and the plus to the plus terminal. Because I would like to show you that I have adjusted already the voltage. Then I will try to switch on. It's 5.5 volts. So this 5.5 is almost the same as the voltage output of this one, the one charging our power bank. So if this one could charge our power bank, much more this one could charge our power bank. Right? Okay, so we are ready to charge this power bank here. We are given now the voltage emanating from my DC to DC converter. Okay, I will try to remove the multi-tester. Okay, I will set this to current now. But before showing you that the current consumption will be something like that, I would like to show you that I made something like this. I cut the terminal of the charger. I cut it in half. I just needed the small USB thing here. Because the small USB thing is the one inserted in the power bank for the power bank to be charged. Okay? And I open the wires. Of course, this white one is the ground. This red thing is the positive terminal. Then I use my soldering gun to make a connection here. Just a piece of wire so that when I connect the clip, okay, it will be thoroughly gripped by this one here, right? Okay, so this terminal here is the one to be used to connect the output of the DC to DC converter, and this is molting here is the one to be inserted on the power bank. This matches because like right now for cell phones, for Apple, this portion here is actually not triangle portion. It's a little bit curved. So just make sure that if you are charging, this small thing here, this small USB, should conform to this one. Because there are new small USB now which are not triangle on the side. It's just like a curved thing for Apple or for iPhone, right? But for Samsung, this portion here is actually a triangle. And I made sure that this one actually is compatible with this one. Okay. This is compatible. This is a cable for Samsung and the edge of the USB is actually triangle. It got an edge, it's not a curve. So this fits in, right? Just make sure this fits in. So the only thing missing now here to charge this power bank is actually the 5 volt emanating from our DC to DC converter. Okay? So I would like to show you. I will be now connecting the what do you call this ammeter to measure the current consumption of the power bank while it is charging. So I'm now connecting the plus and plus, the negative terminal. The ammeter is in series with the positive terminal of the DC to DC converter. And I would like, this is the positive terminal, the extension of the positive terminal. I will connect this to the red thing, right? And for the, hold on. For the negative terminal, from the DC to DC converter, it's connected to the negative terminal of the cable to the power bank. Okay? So right now, the current consumption is 0.337 ampere. And as you could see, the power bank is lighted. It's charging now. Okay, it's charging. You see it, guys? You see it? Okay, I will try to focus my camera frontally or backwards. So right now, I'm using my DC to DC converter to charge this power bank because I made the connection for the terminals. I got the cable. I bring out the plus and minus. The plus and minus is connected to the plus and minus of the DC to DC converter. But other than that, I connected in series an ammeter to measure the current consumption of this power bank while it is charging. Okay? So it's charging now. It looks so nice. Okay? This is the DC to DC converter. Okay, I will try to repeat the operation. The output of this one is AC. It is inserted here. That AC voltage is rectified by two diodes. The output of two diodes will be a full wave. It is inserted inserted to the terminals of the 12-volt regulator. And this 12-volt regulator, okay, this is the output. And I place two big electrolytic capacitors in parallel with the output. Okay, the significance of this is that if we need more current, these two here will help the power supply. So the output of the 12-volt here is injected to the input terminal of this DC to DC converter. And the output terminal is here. It goes out here. This is the positive terminal of the DC to DC converter, and this is the negative terminal. Unluckily, I connected in series an ammeter on the positive terminal of the DC to DC converter so that I could monitor the current consumption of this power bank while it is charging. And as you could see it, the power bank is lighted, meaning to say it is charging. And the current consumption is 0.206 amperes or 206 milliamperes. Okay? That's it. So instead of using this small one here, okay, this one here is the equivalent of this big one here. But I don't want to use this one because I am at home. I'm using this one because the output voltage of this one is same as this one. Because the output voltage of this one, I could adjust it because our DC to DC converter is actually a buck boost, meaning to say the input voltage could be adjusted such that the output voltage will be lower, or it could be adjusted such that the output voltage will be higher. But in this application, I would like that this 12 volt here be adjusted to around 5.5 at the terminals here. Okay, 5.5. So I could use that 5.5 to charge this power bank, in which the output voltage is actually 3.7. This one here is the one we bring if we go to the casino and your cell phone is low but already. You just plug in the big USB here and the small thing will go to your cell phone and you could charge your cell phone if it's low but already if you're in the casino or somewhere else. Okay, that's it guys. This is one application of this DC to DC converter. It is used as a charger for power bank, but it's a must that you should bring out this terminal here. Okay, you do it yourself. Bring out the negative and positive terminal. So this terminal here will be connected to the negative and positive terminal of the DC to DC converter so that this power bank could be charged. Okay, that's it guys. For those of you who would like to subscribe to my channel is at youtube.com/@ProfDVJ If you want to share it, click share. My channel contains mathematics. I uploaded 10 long video format discussions on mathematics already. So for those of you who would like to learn more knowledge on calculus and some other things like differential, integral, differential equation, advanced math, okay, it's all on my channel. It's a long video format discussion. And for the short videos are actually a combination of so many things. And the title is actually the how-to things, how to do something else. Okay? But this topic for tonight is under the long video format topic. Luckily, the topic is on electronics. Okay? Good morning from Los Angeles. This is Professor David J. De Los Reyes.